So let's talk about Gage R&R studies in the measurement system analysis. In the last lesson, we considered the problem in precision that can result from the PCBI viewer measurement tool used by the PCBI Pro to measure distances between components on circuit boards. Remember, precision refers to the variability in our measurements, and we want to know how much of this variability is caused by the PCBI viewer measurement tool. Recall that precision has two components, repeatability and reproducibility. Repeatability is a variation we observe when the same operator measures the same path with the same device multiple times. And reproducibility is a variation we observe when different operators measure the same path with the same device. So now let's perform a Gage R&R study to investigate these two types of precision in the PCBI viewer measurement tool. So the first step in the analysis is to take a representative sample of paths to measure. So for the circuit board components, we choose 12 boards with distances that range from 4.94 to 5.05 mm, which represents the typical range of distances between components. And next, we randomly select qualified operators to take the measurements. At the PCBA Pro, we'll use 5 operators. Our next step is to decide how many measurements each operator should take. We'll take 4 measurements of each board per operator. But before we proceed, so let's review some guidelines that the operators should follow while taking their measurements. The validity of the Gage R&R results rests on the quality of our data. To obtain quality data from the PCBI viewer measurement tool, PCB Pro operators should follow particular guidelines when taking their measurements. They should follow any specified procedures for the experiment. They should take their measurements in random order to help control unknown external factors that could influence the measurements. After measuring each board on and removing it from PCBI viewer measurement tool, they should reset the measuring device. The boards should be secretly marked to avoid operator bias. And finally, operators should record any changes in conditions that may occur, such as temperature or time of day. So now that we know the best procedures for taking measurements, so how should we record our measurements? So let's look at our worksheet where we'll store our data. These two columns contain the operator and the path. Because each operator measures each circuit board 4 times, so the worksheet contains 4 rows for each combination of path and operator. To follow good experimental practice, we'll take the 240 measurements in a completely random order. And finally, we are ready to measure circuit boards. Each operator measures the circuit boards in the order specified in this column. The measurements are stored in the distance column. In the next section, we'll analyze the data using a Gage R&R study. So let's review. To obtain quality results from a Gage R&R study, it's important to follow good experimentation procedures. To obtain quality data, we should always choose a representative sample of parts from the population and measure the parts in random order under typical conditions. In the next lesson, we'll analyze this data using Gage R&R study. Thank you for your listening. In the next lesson, we'll talk about the graphical analysis of Gage R&R study.